How often do you get lost in space? How much do you know about our cosmic neighborhood? The most I remember learning in school was my very excellent mother just served us nachos, which was a planetary mnemonic to remember the names and order of the planets in our solar system. A mnemonic is the name for a memory aid that helps you remember things. So, my very excellent mother just served us nachos. My Mercury, very Venus, excellent Earth, Mother Mars, just Jupiter, served Saturn, us Uranus, I'm going there, nachos Neptune. My very excellent mother just served us nachos. That was the extent of my knowledge of space. Apart from that, I was relatively clueless about what went on out there in the great beyond. Where are we? Anyway, how did our planet form? How close is the next solar system? If you're also unaware and curious, then this is for you. I'm going to break it down as simple as possible. I will start from our immediate solar system and move out, so that by the end of our time together, you will have a better understanding of where we are on the galactic map. Are you ready? That's what I like to hear. Let's start with our sun. Our sun, our sun, our sun. Like we own it. Our sun is a star at the center of our solar system, and it began as a giant cloud of gas and dust. And this cloud collapsed under its own gravity, and it started to rotate. And as it spun faster and faster and faster, the material spread out and formed a big, flat disk around the center where the sun was forming. And the dust and the gas and that disk clumped together. And those clumps eventually grew into planets. And one of those planets was Earth. Since the sun never stopped spinning, it helped shape how and where the planets formed, how big they would be, and how fast they would move. The sun's spin also caused some of the material in the disk to be spread out further away from the center, forming gas-rich planets like Jupiter, while other material clumped together closer to the sun to form rocky planets like Earth. So we owe a lot to that spin. It influenced the entire structure of our solar system. But where did that dust and gas come from in the first place? Dead stars, murked stars. We're a recycling bin, a second-hand solar system made from the leftovers of other stars that lived, died, and exploded billions of years ago. Wild to think about, right? So when stars die, they shoot all their gas and dust into space. And the gas and the dust mixes together in huge, cold clouds. And when these clouds get really heavy, gravity pulls them together to make new stars and planets. We share the same basic materials or building blocks with Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and anything else in our solar system. They are just in different amounts and combinations. The composition of the planets differ depending on the distance from the sun, and the temperature in the disk when they formed. when I was discovering all this, I started to think of the planets in our solar system sort of like our siblings, right? Because they're made of the same materials. But anyway, the planets closer to the sun, like I mentioned, Mercury, Venus, Earth, Mars, mostly solid, rocky, and metallic because of the heat. While the planets that are further away from the sun, that's Jupiter, Saturn, Uranus, Neptune, are cooler and able to collect more gas and ice. And what about the moon? What about the moon, La Luna? According to the most widely accepted theory, a rock the size of Mars crashed into the Earth, and the impact sent debris flying out into space. Thanks to gravity, that debris stuck together over time and formed the moon. The moon's orbit is dictated by a balance of forces. Earth's gravity pulling it inward, and the moon's speed pulling it outward. Now, when we look up at the night sky, we can spot the other planets in our solar system, right? Or our siblings. We can say hi to our siblings. But we can also notice that there are other stars. And those other stars are other suns with their own unique solar systems. So the stars that we see in the sky are like distant neighborhoods. And as the Earth orbits the sun appears to pass through different distant neighborhoods, otherwise known as constellations. Maybe you've heard it's Aries season or it's Taurus season. That's because our sun appears to move into a new constellation or neighborhood as Earth completes its orbit. And just like each neighborhood has its own energy, style to it, so do the different constellations. This is a very simplified way to explain how astrology works. This city of stars that we can see with the naked eye, which, by the way, is only about 3,000 stars on a good day without light pollution, they all orbit around the galactic center of what we call the Milky Way galaxy. To boil this down for you, let's try considering the Milky Way galaxy as our province, and our province contains between 100 billion to 400 billion, but we really have no idea, other stars or provinces orbiting around the galactic center. And that's just within our galaxy. So, if you are adventurous and you can leave your planet, then within our galaxy alone, you've got a lot of exploring to do. You have a lot of different solar systems to see. Right? Right. But what about the galactic center? It's a supermassive black hole. Well, not all galaxies have a supermassive black hole as their galactic center. Most do. And the galactic center is where the gravitational forces concentrate the most, creating a pull so powerful it not only controls the orbits of the nearby stars and the gas clouds, but the formation, evolution, and regulation of many stars in the galaxy. If you're ever interested in looking in the direction of the galactic center, all you have to do is find the constellation Sagittarius, and that is the direction that it's in. So, get one of those star apps, or memorize the constellations in the sky. Find Sag, hone in, there's the galactic center. Where are we in relation to this supermassive black hole that is towards Sagittarius? Well, we are in one of the galaxy's spiral arms, known to us as Orion's arm. It's about halfway from the galactic center to the outer edge. And the outer edge is the transition zone where stars become fewer and fewer, while the spiral arms are the hot spots for star formation. The more defined arms, because there are multiple arms, contain a heavier mass and more stars. And as you can guess, the minor arms contain less stars and less mass. But let me continue to blow your mind here. Did you know that there are different types of galaxies? Did you? We are in a barred spiral galaxy, but not all galaxies are a barred spiral, and not all galaxies even have arms, but ours does. The bar in the center is like a cosmic spine that runs straight through the middle of the galaxy, and its gravitational force is partially responsible for shaping the spiral arms that we are currently located in. It also pulls gas from the outer regions to the center, so new stars can form. While the 400 billion stars and multiple spiral arms in our own galaxy might seem massive to us, that's just a drop in the bucket. We are one of 54 galaxies in a local group of galaxies. It might be helpful to think of our local group as 54 different countries. Or it might not. You decide. Either way, our closest neighboring galaxy is Andromeda, which is also a barred spiral galaxy, but way larger, because while we have 400 billion stars, Andromeda contains 1 trillion stars, and our galaxy is set to collide with it. Don't panic, it's gonna happen in 4.5 billion years, but when that happens, it allows a new, larger, elliptical galaxy to form. And what happens then? Primarily new stars. It seems like the name of the game is new stars. For pre-existing stars, before the merge, the gravitational forces, orbits, and structures will undergo a massive change. The central black hole will become larger, resulting in a new galactic core. But the likelihood of actual pre-existing stars colliding is slim, which surprised me. So, they won't completely obliterate upon impact, but everything about the pre-existing solar systems will shift upon this collision. Within our local galaxial group, our next closest neighbor is Triangulum. Of the 54, the Milky Way and Andromeda are the largest, and Triangulum is the 3rd largest. Triangulum is also a spiral galaxy, but it does not contain that central bar or spine, which is likely why its arms are more patchy and less defined than the Milky Way. There are only about 40 billion stars in Triangulum, so those are the 3 main galaxies in our local group: Andromeda with 1 trillion, Milky Way 400 million, Triangulum 40 billion. The rest of the galaxies in our local are smaller dwarf galaxies, or smaller satellite galaxies that orbit larger galaxies. Satellite galaxies usually do not have any current ongoing star formation and only contain older stars. Now that we have our countries down, let's consider our continent, shall we? And that is the Laniakea Supercluster. I hope I'm pronouncing that right. Laniakea. The Supercluster has approximately 100,000 other galaxies in it. Our local group of ourselves and 100,000 other galaxies is located on the outskirts or fringes of Laniakea, very far away from its center. At the center of the Laniakea Supercluster is the Great Attractor, and this exerts a gravitational pull on the rest of the galaxies within the supercluster. Laniakea is part of the cosmic web, and the cosmic web is a vast interconnected network composed of long, thread-like structures called filaments, voids, superclusters, and dark matter. Beyond Laniakea are other superclusters which make up other points of the cosmic web. So, if Laniakea is our continent, then the cosmic web is our world. And this cosmic web is what makes up our known universe. We have not yet discovered another universe to suggest that we are in a multiverse. However, we may also lack the technology to detect them. We can only see a tiny fraction of the entire universe at the current time. But it's safe to say we have a lot of ground to cover and exploring to do based on what we know already. So what do you think? Is this your first rodeo? Can you remember any of your experiences before? If our dust merely gets recycled, then this can't be our first time, right? What do you think? How do you feel about our position within the galaxy and within the universe? I would love to hear any grounded or wacky thoughts you might have on this, so please make sure to share them. I would love to open up a conversation. And thank you so much for subscribing to this channel. I really enjoy sharing mind-bending excitement with you. And also, get a load of this sweater.